normally I do Kubernetes security in critical infrastructure, energy, healthcare, and also the German government. I was partner of EndoCode, and now I'm one of the founders of Mitigant, and I have several pro bono memberships. For example, the INEC, a German organization which cares about healthcare and digitalization, also in the German Planning Committee, and so on, several of these pro bono memberships. Yeah, but now let's go into Kubernetes. What's a landscape? What's actually happening here? And normally my general map I'm following is this DevSecOps guide by the CNCF and also the US Department of Defense. So if you do DevOps, then you probably know the inner part of it. It's all about how to develop, build, test, release, and so on. And then on the delivery side, you deploy, operate, and monitor and feedback it. And if you add the security to it, then you have 14 more of these little topics where you have to, for example, analyze a threat model. You can do secure coding and so on the coding side. You have a lot of options, digital signing. So I'm also in a digital signing project here in Germany. And then what we are focusing on is more or less this part: security config, security scanning, patching, a little bit of auditing and monitoring. So we are focusing on the operational side of this DevSecOps model. In the presentation, you will get the presentation. There are the links to the documents. So you will have everything as a PDF at the end. So let's look. Oh, what happened? Clicked on one of these links. Effectively, what's security chaos engineering practice? You scan for vulnerability, then you fix it, you patch it, you fix it, and finally you monitor if everything works well. So this is what you need to do, and you have to do it on scale, because in a typical Kubernetes cluster we have a lot of objects. I will show you some numbers later. Our security model, basically what you see always is this model. Here you have the internet, and here you have several zones, DMZ, client security zone, high security zone, and a restricted high security zone. Effectively, this is this kind of model. If you compare it, effectively, it doesn't look so new. It's a medieval castle design. This is exactly the model we have. We have typical architecture: one mode, two walls, towers, bridges for access. And what you don't cover, for example, is the access rules to this gate here. Or what happens if you have an extra tunnel below the external wall, something like this. These are the typical things which are not mentioned. By the way, there is a link to the Belvoir Castle Wikipedia entry. It was quite successful because they surrendered after 18 months of siege, so it was not so bad designed. But in our time, what do you do if we have effectively this kind of situation? So where do you want to put the moat? Where do you build a wall? This is what we see at the moment. So we have a much more dynamic situation in our environment, in the clouds and in Kubernetes especially. This means we need new concepts and new ways of dealing with the security challenges we have in this kind of battle. Some days ago, if I gave training, I just asked the question, so it's like a capture the flag game: can my cluster be owned? Can I get into a cluster and take over the cluster admin role and what is necessary to do this. And effectively, this gives me a definition of security in depth. How deep is your security means how many minor flaws I have to connect to capture the flag. And the flag is here, as in Kubernetes, is a cluster admin role. You definitely need to do some action to do this. And it's all described in this OpenShift hack. It's on GitHub in Jupyter Notebooks. This is the way I do my trainings normally. And here you can have all this. It starts with a vulnerable application. So here I use image tragic. I could also have used log4j, but image tragic is more, let's say, direct. And for log4j shell, you need kind of more sophisticated setup. So who's responsible for that? So every developer or many developers from time to time make mistakes. So it always can happen that one of your applications is vulnerable and you can have a vulnerability. And then this must be covered by the other layers. In Kubernetes, we had up to 1.23 the service account token by default. And I claimed this is a Kubernetes design flaw, and they fixed it in 1.24, which is story one slide later. And then with this typical images, you have the image creators are not very careful. Most of the image have some kind of vulnerability. Most you have kind of curl into it, but an echo or a cat would also be sufficient. You can add additional software. Maybe you have an apt and you can apt install software on that. And here in that example, I would use kubectl just for convenience. And then there's a typical mistake you can get if you or your colleague adds a role binding to cluster admin roles. This is not so common, but this happens even big vendors. For a long time, Elasticsearch had in its Helm chart a cluster binding to the role binding to the cluster admin role, which is not your responsibility, but your colleague might have installed Elasticsearch in the same namespace, and then you have this. And now you have, okay, Kubernetes service account, your application is vulnerable, and the image creator has done something poorly designed image and role binding, and then you have total access to the cluster. And as a bonus, because this is also a colleague who is working in Azure a lot, you can hijack not only Kubernetes, but the entire Azure account. This is Nico Meisenzahl who is telling that story. And this is quite a problem in cloud accounts if you not only have a service account token in your pod, but also on the Kubernetes node, a service account token or similar cloud account token, some token which gives you access to the entire cloud account. Okay, let's continue. How do we avoid security issues? Okay, according to that model, do a threat analysis first. Don't create security issues. Scan your source code. Do a statistical analysis, for example, SonarQube. The professional version is very expensive, so most people don't do dynamic analysis. This is OWASP. You can do it. You can scan your containers before deployment and block them. This is part of Arbor and Trivy. You can do it. A very special challenge is, yes, you should harden your containers on the higher security levels, because then if the less code you have in your containers, the less binaries you have, the less is the probability that something is vulnerable. You can detect it in production. You can scan it, you can monitor the behavior, and you can fix it in production. For example, as we do it with security chaos engineering. Oh, yeah. And then finally, you can mitigate it. You can update your rollouts and change and patch your configuration. We will see examples of that. So this is the history of the service account token a little bit. The problem, as I mentioned, is here. Every container, normally until 1.23, has a service account token. And then I discovered this, and then in June 2 years ago, there was a discussion in Twitter space, and the service account token effectively is a doormat attack like thing. You have a key under your doormat or under your flowers in front of the door. And this gives the attacker immediately access to your door. And in that discussion, it was on Twitter Spaces, I raised this issue, and then yes, you are spicing up the discussion. So the developers don't like the idea that their debugging features, and the service account token is also very comfortable for debugging, are also security problems. Okay, you don't like it, but it's part of my trainings, and then I put it on stage in a Chaos Computer Club event on hacking containers, Kubernetes, and clouds. The video is still available. And then I received a wake-up call, which was very friendly from Red Hat. So they called me, and I had a discussion with Sam Fowler in Australia and Sebastian Hetze here in Berlin. We talked about this, and then they thought, okay, it's mostly not needed. If you are not running an operator, you don't need a service account token, period. And then the solution appeared. Oh, this was too fast. This means you have, they simply have removed it. This is a kind of security chaos engineering. And if you look into the code, you see the 1.24 kubelet looks for service account tokens and simply removes it. Is this issue fixed this way? No, I would not say. I found Kubernetes clusters with a version below 1.24 still in use. The entire process takes years. And as I've learned here, pushing security into a development-oriented community can be hard. This is a problem we will have to address, and in several parts. So, yeah. Example from the trenches. So this was effectively last week, March 2023. I looked into a cluster of a customer, critical infrastructure. I don't say which, because it's quite unique in its area. It's a software and service provider, so it deploys its software in customers on scale. And also for smaller customers, it does a service. We have typically 100 containers per cluster and found on an average 12 configuration issues per container or per pod. Starts with simple things like missing limits, no security constraints, no network policies, service account tokens on scale. And if we look into it, he has hundreds of customers worldwide. So this means we found more or less between 5 digits and a 6-digit number of vulnerabilities worldwide. Hopefully they are isolated in a network, but I'm not sure everywhere. And if you have an issue in this thing, then your critical infrastructure is affected. This is not an online shop. This is not kind of pizza delivery service. This is a real critical system. Okay, we have to care about this, and this means we have to fix it on scale. How can you fix it? This is a very good example of security chaos engineering scripted. If you have a CI/CD pipeline, you can add network policies automatically. And there is a very good example in the net. You simply add a TCP dump sidecar, and effectively it's running besides your port, or in your port besides your containers, and gets the traffic and analyzes the PCAP files which are generated by TCP dump. And finally, you have a running Python script, something like that. And then you create the network policies yourself on scale. This is an example how you can do it. And then at least you have fixed this issue that you cannot create, or you cannot download additional malware or can communicate to your mothership from the malware inside the container to the outside world. So this fixes a lot of problems, not everything, but it's a good starting point. It's all available on GitHub somewhere. Now, the next bad thing, and the real issue is, what about the container images? Normally, we scan with Trivi and Gripe. And if you look into the image, even from important vendors, you have round about 150 CVEs, 20% of them are high or critical. And this means 150 are the typical thing. We once had a game. Yeah, we have a new container from Microsoft or Red Hat. Let's estimate how many vulnerabilities they have. And then the guy who was closest to that number has won the game. And if you look into it, the all-time high, again, is OpenSSL. It even affects the up-to-date version of Alpine images. My personal record was around about 750 CVEs in a container, which should go into critical infrastructure. And then you talk to the people, oh, our CISO is checking all images. Oh, really? Let's check it again. And then we found a Log4Shell issue again, which should go into critical infrastructure. And this is a serious thing. And if you don't scan the images, then you're really, open for this kind of vulnerabilities, and you should fix it as soon as possible. But this is quite an effort. By the way, we had an event 2 days ago with Christian Grobmeier. He is one of the Log4j developers, and Brian Behrendorf, and the German Federal Office for Information Security, so BSI, also Bundesamt für Sicherheit in der Informationstechnik für die Deutschen, and had a very interesting talk about this, how they handle it, how they have fought against it, and they have worked really hard, 24-hour time shifts to get it under control, and this was all for free. And if you see a lot of discussions about, let's do security, Log4j dev is one of, Log4j shell is one of the examples. Nobody is talking to the developers. So they have been completely unaware about this black hat talks of people hacking the GNDI interface, and they simply do not look into that direction, was the outcome. And one of the issues today is also if you download Log4j or look on the downloads of Log4j at the moment, 34% of the downloads are still downloading a vulnerable version of Log4j. It's quite an interesting talk, again, 1 hour, and gives a lot of insight. And the problem here is, do you really want to discuss every CVE? So if you have 100 CVEs per container, that sums up to, in the thousands, maybe 10,000 in a typical container environment. You cannot mitigate 10,000 vulnerabilities. You cannot discuss 10,000 of them. Maybe you can discuss 100, And then you have to triage them. Is this important? Is this not important? Are we affected? This means we have to start to enforce distroless containers. I've started this in a German government project, but educating the developers to deliver a distroless container which does not have all these vulnerabilities or much smaller numbers of vulnerabilities effectively takes 1 year. So pushing the problem back to developers means you have to accept for 1 year that they cannot deliver, or you have to live with the vulnerabilities in their images. And this means sometimes mitigation is the only way to go. So we cannot fix everything at once. We have to push for the right solution and the security. But at the moment, we are in a situation where we definitely don't get clean containers. So we need this kind of isolation, and we need to scale, and we need to mitigate on scale. Yeah. Okay. This is the past and the current of security chaos engineering, but what is the future? Please scan all your containers with, or all your environments with Kubescape. We'll definitely integrate it into our product. Kubescape, by the way, flags the service account token as low. I will show you that this is a little bit optimistic. There are no ideas of using graphs for SLSA and the SBOM, so Google started it. And if Google starts to look into one direction, it's a good idea to look what Google is also doing here. So if Google creates graph, it's probably a good idea also to use graphs. Can we do more? Yes, we can. And now it's time for the lab. And effectively, we will do a demo. This is a warning. The tool who is able to scan for vulnerabilities can not only be used for defense, it also can be used for attacks. Therefore, we have not published so much about it, but now it's demo time, and we have imported all the graphs into a Neo4j database. And how does it look? This is the way. I have to change the tab. Yes, this one I've prepared in Neo4j database. It's running in the same cluster as a Neo4j, as an Kubernetes deployment or a stateful set. It's a stateful set actually. And let's look what it shows if you do a full scan of all objects. So these are all the objects you can see here. I don't know if it's big enough. I try to increase it a little bit. Yes, looks better. And here you see we have service accounts, we have labels, we have pods, containers, services, CVEs. This is not a Kubernetes object. It's just added to have a connection. We have roles, cluster role bindings. And we have relationships between these objects, so created by, labeled by, selects. This means there's a connection between the pods and the services. A pod contains images. We have a vulnerable relationship, we have a cluster role binding. So this all makes sense if you look deeper into it. All these clusters here are applications. This is a kube system namespace which is connected. This is another thing in kube system. And here we have actually Where are we? Again, in the kube system namespace, here we have the cluster role, cluster admin, which is a dangerous one. And here we have a different namespace, neo4j. And I planted this vulnerability here just to show that you can find it. And here is a kubescape running in a kubescape namespace. And I also experimented with memgraph. So there are still remains of this memgraph. I will answer on kubescape later the question. Yes, thank you. And here, let's go to a more sophisticated query. So this is more or less give me everything. And here I have just a query which says, give me all connections between a CVE and the cluster role. So this is a special thing of the Cypher query language, which is typical for graph databases. You can simply say, hey, give me that kind of connection. This means give me every connection between a CVE and a cluster role. And I simply can click this, yes, it regenerates, and then I have to rearrange this. It really looks like a molecule. And here you see, here's the CVE. Funny, it's green, but image tragic is red. So this is the dangerous part. Here is a pod, which is a proof of concept pod. And here's the default account in that namespace. You see it's a neo4j namespace. And here's the cluster admin role. So you can see there is a direct connection between the vulnerability and the cluster admin role, which is more or less the hack I have presented on stage. And this means we definitely see if we have this kind of connections. Let us do more sophisticated things. So if you just yes, here's a different query. This query simply says, yes, it's the same query as here, but please give me also the CVEs which are attached to a service, which means I have the connection between a CVE, a cluster role, and a service means it is exposed to the outside world. And let's see here, and now we have a different setup. Here again is the CVE, here is the vulnerable image, the pod, and this is service. The brown bubbles on the surfaces here, and on the other side you see the default account here. This means we have a very dangerous situation because now the cluster admin role is exposed to the service by a vulnerable CVE. And by the way, because we have used the same namespace, also the neo4j deployment has been created by this default account, which has this connection. So if we would have a vulnerability in neo4j, then this also would mean, yes, we have exposed our cluster admin role in another service. So this very much shows you that we can find this kind of vulnerabilities by analyzing graphs, but this all has to be polished and cleaned up, and we will see how this works in the future. Because I want to share something with you. We have here now, just go a little bit to the Jupyter notebook. What you can see here is these are the kubectl commands to create this entire environment, namespace, context, and then I use the standard Helm chart of Neo4j for a release and add simply some plugins, change the limits a little bit to have a faster response, 6 CPUs, 8 GB of RAM, which makes it really faster. Here is how it is rolled out. I have a password, which is very simple. You get all these things. It finishes quite fast. Here you see I can add the Cypher queries in a config map. And then the secrets are not really used. Then I can create a batch job, which uses these Cypher queries to go into the database. And then here you see just a pod for testing. And here you see the log files. So it's importing all the data. And effectively, it's using a kubectl without password, which runs in another window here. So this is all open. And here you see I have changed it to, patched it to load balancer just to have the Minikube tunnel mechanism working. And here is the artificial creation of the cluster role binding to show you the connection. And finally, what we can see is we can pipe Cypher queries into Neo4j, and this is one at the end of the day we will get into our application and present you in a hopefully much nicer way than here. And at the moment this does not work with JSON, but this is very close to JSON. Effectively, this is how this will go into our product, hopefully. Okay, we are at the end of the demo. And just continue. We've seen you can get a lot of information in a Cypher query. And by the way, this is a very small Minikube demo cluster. So in a real cluster, this would be much more dramatic and impressive. You can connect all the CVEs and in a graph with the cluster, with all the objects in Kubernetes affected. This is kind of nice. And here you have also the CVEs exposed. So this is basically what we have learned in this lesson, that you can use graph databases for analyzing Kubernetes security. And by the way, this is not limited to Kubernetes. We also could push everything from, if we have the CVE here, if we would have source code information here, we could put source code information here. And if we could run cluster admin on a node, we could even put the cloud accounts here. This goes beyond the possibilities of Kubernetes. Therefore, I cannot use it in Minikube, but effectively we have a lot of more opportunities here, which we can show in larger graphs. And then we are only limited by our ability to present this kind of graphs in a nice way. This will be the challenge at the end of the development. So outlook, yeah. What we've learned, scoring vulnerabilities is hard, as fixing is. We can connect low and medium vulnerabilities, and then they become critical. It's on our roadmap. Definitely we will need some time. And we are very carefully with publication of this at the moment, because graph-based tools can also be used for attacks. This will be one of the challenges, that you don't get it as an attack tool. So if I want to summarize, effectively in cloud security, we are not dealing with individual CVEs anymore, but we have hundreds, thousands of them. Even manual pen testing needs automation nowadays, so you need a tool for that. Regular daily scanning is a must nowadays. You need to detect if some new CVE has been found in your infrastructure in the last 24 hours. You need reaction times smaller than 1 day, sometimes. Security chaos engineering can help you. At the moment, you do a lot of things manual, so there's a plot with network policies was more or less semi-manual, but it worked. This must be automated in the future. And for the developers, the hard news is image hardening is necessary nevertheless, but we have bought some time before your images get hardened. Okay, now we are close to Q&A. Here you have my addresses. And yeah, I give back to Kennedy, and we've collected all the questions.